Hello students, and welcome to the series of Q. As in previous lecture, we have discussed how to insert an element in Q. And now in this lecture we are going to discuss how to remove an element or how to delete an element from Q. Okay, as we know that the different terms, that is front, rear, Q. Okay, so front and rear both hold the location of first and last element from the queue respectively. So, and in the first or second lecture of queue, we have discussed what procedure we have to follow after removing an element from queue. So just remember that queue is nothing but first in, first out. That means whatever element or whichever element we have inserted at the first time, that element we have to remove at the first, and then of second element, and then third element. So whatever deletion takes place, that deletion takes place from front end only. So remember, insertion takes place from rear end and deletion takes place from front end only. So this is an algorithm to delete an element from queue. So first step, as I said in previous lecture, while writing an algorithm, we have to consider all the possibilities related to that problem, right? So this is an algorithm to delete an element. So first step I have written over here, that is if front is equals to null. So remember that now we are going to remove an element from queue. So what first step we have to do, or which step first we have to check? Simple. As we are going to remove an element from queue, first we have to check whether an element is present in that queue or not. By default, we are going to remove an element from front end only. So first we have to check whether element is present or not. So in previous lecture we have discussed, that is if front is equals to null, what it indicates? So here I have shown one diagram. So this is a queue, okay, linear array by the name queue. Okay, we can store 4 elements in this queue. So here in this case, if we look over here, we are having front and rear. Okay, 2 pointers we are having which hold the locations of front and rear element. So here in this case, if we look over here, no single element present in this queue. So it means that front is equals to null and also rear is equals to null. So when front is equals to null, what it indicates? Our queue is, when front is equals to null, it indicates queue is empty. So as queue is empty, we cannot remove an element from queue. So this is the first check. While removing or while deleting an element from queue, first we have to check whether element is there or element is present in queue or not. So this is a condition to check that. If front is equals to null, it indicates that our queue is empty. So if queue is empty, we cannot remove an element. So simply we write underflow and we exit from an algorithm. So this is the first step for deletion of an algorithm, that is we have to check whether element is present or not. So if element is present, we simply write underflow and we exit from an algorithm. So if suppose elements are present, then what we have to do? So for that we have written second and third step. So second step, what I have written, so in the second step, what we have to do? Whichever element we have to remove, we have to store that element in another variable. So to store that variable, we have used, to store an element, we have used another variable, or we have used one variable by the name item. So what the second step does? Simply it store element in this variable item. So whatever element present at the front will stored in this variable item, right? So this is the second step. Now third step, as I said at the start, we have to check all the possibilities while removing or while writing an algorithm. So different possibilities are there again while removing an element from queue. So let's go one by one. So this is the first possibility I have written over here. that is queue is present, and if only one single element is there in that queue, so how to remove that, or what procedure we have to follow? So in this case, if only one element is present, then what is value of front? So in this case, front, only one element is there, it means front and rear both are same. So front will point to the second location as well as rear will point to the second location. So it indicates my front. So it indicates only one element is there, that it means that this is a front is equals to rear. So when this front is equals to rear, it indicates only one element is there. So if in this case, what we are going to do, if we are going to remove one element, then what we have to set? We have to set, after removing, our queue becomes empty, then what we have to do? We have to simply set front is equals to null and rear is equals to null. As only one element is there and we have removed that element, so our queue becomes empty. So we set front and rear both to the null value. So this is the first possibility. Then again we are having the second possibility, that is, if front is equals to n, and if front is equals to n, what n indicates? N is the maximum size of an queue. So here n is equals to 4, that is, we can store maximum 4 elements in queue. So here in this case, consider our front is equals to 4, that is, front is equals to n, and here rear is equals to 2, right? So front is equals to 4 and rear is equals to 2. Now in this case, or now suppose we want to remove an element in this case. So as I said, we are going to remove an element from front end only. So in this case, we have to remove this D. So if we remove D, we cannot increase front by 1. So if we do front is equals to front plus 1, then we'll set value of front to 5. But fifth element, or the size of this queue is 4. So we cannot go beyond that. And as I said in previous lecture also, we are considering queue as a circular queue. So just consider this as a circular queue only. So as in the previous lecture also, I have shown one diagram for circular queue. So I will represent this in a circular format. First, second, third and fourth index, as I said, D, E and F. Okay, total 3 elements are there. This is our front and this one is our rear. Now suppose I have to remove this element. So after removing this element, where I have to move? I have to move to this first location. So simply in such case, that is, if front is equals to n, then what we are going to set? We are simply setting this front. After removing that element, we are setting this front to the first location. So I have directly set front to the 1. Okay, so this is second possibility. Now third possibility, that is general possibility. Total 3 elements are there. So in this case, my front is equals to 1 and rear is equals to 3. Now I have to remove one element, so obviously I will remove this element which is present at the front. So I will remove this A, and after removing, simply I have to set front to the next location. So simply front is equals to front plus 1. So that I have done over here. Okay, so these are the different possibilities we have to consider while removing an element from queue. So I hope you understand why I have written all these conditions. Okay, so this is the first condition. Okay. Only one element is, this is condition when only one element is present. The second condition, when front is at the last location, and third condition is for normal elements are, when the normal elements are present in queue. So just remember, we have considered this as a circular queue. Okay, so I have drawn this diagram of circular queue in this lecture also, and we have discussed the same in previous lecture also. So I hope you understand this, why I have written all these steps. So let's discuss the same algorithm with the help of one simple example. Okay. So I will take one simple example. Again, 3 possibilities are there. I will choose one of the possibility and accordingly we'll solve this algorithm. So now, as of now, just consider okay, I will choose this second step. Okay, or say not second step, I will choose the second possibility. So this is my queue. 4 elements are there. So this is D, this one is E and F. So in this case, so as of now just consider this. So in this case, my front is equals to 4. That is, this is my front and this one is my rear, it is second. So we have discussed this in previous lecture that after removing the elements from Q, we got this position. Okay, so for this, for reference of this, just go through these previous lectures. Okay, so now consider this possibility. This is my Q. Now I have to remove one element from this Q. So first step, obviously we have to check whether Q is empty or not. So if front is equals to null, so but in this case front is equals to 4, so this condition is false. So as this condition is false, we are not going to print or we are not going to write underflow. We are simply moving towards the second step. And in second step, what we have done, we have simply set item is equals to Q of front. So here I will write item is equals to Q of front. So Q is the name of array and value of front is equals to 4. So Q of 4. So this is a Q. Q of 4 is D. So I will set item is equals to D. So this element we have to remove. So before removing that element, we have to set that element in another variable. So here in the second step, we'll store the element in the variable item. So next, now we'll go to these steps. Step 3, if front is equals to rear. So here in this case, what is value of front? Front is equals to 4, rear is equals to 2. So 4 is equal to 2. No, it is not equals to 2. So my condition is false. So it will not go into the if, it will move towards the else. So again else we have written if else, right? So again else we have if else. So again we have to check one condition. Here if you check if front is equals to n. So as I said n, here I have mentioned n is nothing but it is a maximum size of array. So here maximum size of array is 4. So in this case n is equals to 4. Right. So what condition we have? If front is equals to n. So value of n is equals to 4 and value of front is equals to 4. So here 4 is equals to 4. Yes, condition is true. So as condition is true, our control will come inside this if. In if, what we have done, we have simply said front is equals to 1. So simply we'll set front is equals to 1. So as we have removed this, we'll set front is equals to 1. Then as our if is true, it will not go into the else. So it will skip the part of else and it will directly jump towards the fourth step, and we have here we have written exit. So it will exit from an algorithm. So while exiting from algorithm, what we have? We are having front is equals to 1. So it will point to this location, and rear is equals to 2. So rear will point to this location. Right? Initially 3 elements were there. Then after execution of this algorithm, we have removed one element which is present at last location and we set front to the first location. So it means we have total 2 elements as of now. So I hope you understand how to delete an element from an queue. So remember, here we have considered this algorithm, here we have written this algorithm by considering Q as a circular queue. Right? So this is a simple algorithm. So in next lecture, we'll discuss the next part of this queue. So before ending of this lecture, just take a quick review of this, whatever I have written in this algorithm. So in this algorithm, first step is to check whether element is present or not. Okay, if it is not present, we'll simply write underflow and we'll exit from an algorithm. In second step, we have assigned element to the element which is to be deleted to the variable item. Then in third step, okay, we have actually changes the position of front. So if this condition is there, that is front is equals to real, that means only one element is there, then we'll simply set front and rear to the null. And again, if second possibility is there, if front is equals to n, then in that case, we'll rather than increasing value of front by 1, we'll simply reset front to the first location. And in third possibility, we'll simply having normal queue. Okay, only 3 elements are there, and in that case we'll simply set front is equals to front plus 1. Okay, and then we'll exit from an algorithm. So this is about this deletion of an element from queue. Thank you.